A very good morning, everyone. I'm DANAASRI Nagendra, C23A1068 from Group 10. Would like to introduce an exciting concept called mouse touchscreen, a mock-up innovation that combines the traditional computer mouse with the modern touchscreen technology. As we know, the computer mouse has been a key tool in computing for decades. It's simple, effective, but still limited with what it can do, mostly just moving cursor and clicking. On the other hand, touchscreen technology has become a huge part of our daily lives. We use it in smartphones, tablets, and even laptops. It allows us to swipe, zoom, and interact more naturally with our devices. So, what if we could bring these two technologies together? The goal of this innovation is to create a smarter and interactive input device. By editing a touchscreen surface to the mouse, users can do more, like scrolling with a swipe, zooming with a pinch, or even using gestures for shortcuts. This project is still in the mock-up, but it represents a fresh approach on how we interact with computers, especially for designers, gamers, and professionals who want more control and efficient. I think that's all from me. Thank you.
My name is AISYAH BADRINA BINTI YUSOF. So for my part, which is idea and insight, in today's fast-paced digital environment, users, especially professionals and students, require more efficient tools for multitasking. Traditional mouse, limited to the basic cursor movement and clicks, are no longer sufficient due to the lack of gesture control and rigid functionality. Although touchpad offers some gesture, they often lack the precision and comfort needed for the longer or complex tasks. The innovative touchscreen mouse combines an LCD touch displays with a physical mouse to offer a more dynamic and versatile experience. Key features include gesture-based control, such as swipe, pinch, rotate with a higher precision, customizable virtual shortcuts for different applications, quick access tools like menus, notification, or a mini calculator, designed with a focus on ergonomics and adaptability. It aims to support different use cases, which like work, gaming, and browsing, while encouraging a natural hand posture. This device reimagines everyday computing by enhancing workflow, accessibility, and control in one compact input device.
When idea and future planning identified key features, gesture control, multitouch, customization, design for modern, professional, creative students, and multitaskers, recognition, shortcut, tool, Intel design, pace, sketch, ergonomy, sheets focus on comfort and functionality, and create 3D model using SolidWorks and Fusion 360, evaluated hand grip, finger reach, and component placement. 3. Material and component selection, touchscreen, flexible, capacity display, smartwatch grade, and sensor height precision, optical sensor for accurate tracking, connectivity, Bluetooth low energy, BLE for wireless use. Battery have a compact, rechargeable lithium polymer battery, casing durable ABS plastic, lightweight and comfortable. 4. Prototype development, 3D print shell assembled with source component, test hardware, integration and internal layout balance. 5. Software and firmware integration, development firmware for gesture control and shortcut mapping. Build a simple interface for user to customize 6. User testing and interaction, test with designers, students, and officer users, and collect feedback on comfort, accuracy, and gesture control. Next, improve with palm rejection, haptic feedback, and ergonomic tweaks. Lastly, 7 final upcoming functional uses focus prototype ready for market testing. Combine traditional mouse precision with smart touch features.
User needs analysis, targeted professional, student, and creative. Identify demand for gesture control, multitouch, shortcut customization, and dual mode use. Concept designs. Early ergonomic sketches focus on grip, comfort, and intuitive touch zone. Refine using SolidWorks and Fusion 360 for optimal shape and component fit. Component selection. Curve capacitive touchscreen, like flexible height sensitivity. Precision optical sensor for accurate tracking. Low power Bluetooth model for wireless connectivity. ABS plastic casing for durability and lightweight comfort. Prototype development. Compact integration for all components into a 3D printed shell. Maintain balanced hand comfort and internal layout efficiency. Software and firmware integration. Custom firmware for gesture recognition and touch control. User interface for configuring shortcuts and visual buttons. User testing for iteration. Tested by professional students and developers in real environments. Collected feedback on usability, accuracy, and comfort. Design refinements based on feedback. Improve touch sensitivity and ergonomic shape. Added plum rejection algorithms and haptic feedback for better user interaction. Final outcome. Intuitive, high functioning device ready for market, and combine traditional mouse precision with smart touch feature for modern computing.
Good day everyone, my name is Darshini Gopinathan and I'm gonna present about market evolution of touchscreen mouse. The touchscreen mouse is primarily designed for professional users such as graphic designers, video editors, and CAD engineers, software developers, and UI UX designers. These users frequently work with complex and demanding software like Adobe Creative Cloud, Blender, AutoCAD, and Final Cut Pro. For these professionals, the touchscreen mouse offers significant advantage, such as gesture-based shortcuts that speed up their workflows and reduce dependence on keyboard commands. Its customizable touch interface also allows for greater precision, making multitasking more efficient and seamless during creative or technical tasks. Apart from professionals, the secondary market includes students and educators, especially in fields like engineering, design, multimedia, and architecture. With the rise of hybrid learning and digital collaboration, there is an increased demand of compact, affordable, and multifunctional input devices. The touchscreen mouse fits this requirement perfectly by offering both traditional and modern features that enhance productivity in educational settings. With compared to current market leaders such as Apple Magic Mouse, Logitech MX Master Series, Razer, and Corsair Mac, the touchscreen mouse stands out because of its integrated captive touchscreen. This feature supports multi-touch gestures and app-specific shortcuts, allowing users to switch smoothly between pointer control and touch input. This is something that exciting products do not offer, giving the touchscreen mouse a unique position in the market. In addition, the mouse includes a companion application that enables users to create personalized interfaces and commands according to their specific task or software needs. Whether for creative design, coding, or gaming, this customization feature makes the mouse highly versatile across various disciplines. In conclusion, the touchscreen mouse bridges the gap between the traditional mouse and the modern touchpad, setting a new standard for innovation in computer input devices. Its unique combination of features make it well suited to meet evolving demands of both professional and educational markets.
Hi, my name is Fatin, and today I will present my part, which is product engineering. There are 8 of it. First, multidisciplinary engineering approach. It combines hardware, software, and ergonomic design, and also focus on performance, comfort, and wireless efficiency. Next is technical feasibility and component integration. Integrated, which is capacitive touchscreen, curve for gesture input, high precision optical sensor, microcontroller, Bluetooth low energy, BLE module. It also maintains responsiveness and compact design. Next is power management, smart firmware with sleep-wake cycles, and energy efficient for prolonged wireless use. Next, mechanical and internal design. Created using SolidWorks and Fusion 360, it balances internal layout for natural grip and proper click zones. Components arranged for weight distribution and comfort. Next is software and firmware features. Custom firmware for real-time gesture recognition, palm rejection to avoid accidental input. Companion desktop app for personalized virtual buttons, app-based shortcuts, and custom interface layouts. Next, prototyping and testing. Tested across user groups, designers, developers, students, evaluated touch sensitivity, pointer tracking, ergonomics, and durability. Next is design improvements based on feedback. Improve haptic feedback for gestures, optimize click tactility, and enhance Bluetooth pairing and reliability. And lastly, outcome. A refined, smart, and user-friendly input device seamlessly blends traditional mouse control with touch innovations.
Next is market or pilot testing. Pilot testing were tested at university labs, design studios, and innovation hubs. Target test users were students, professionals, gamers, and tech enthusiasts. Software used for this evaluation were Adobe Creative Suite, which is Photoshop, Illustrator, and Premiere Pro, AutoCAD, Final Cut Pro, Blender, Visual Studio, Unity, and Figma. Feedback focus areas will focus on gesture recognition accuracy, ergonomic comfort and long use fatigue, wireless performance, and software integration and customization experience. Next is competitive edge. Outperformed Apple Magic Mouse, Logitech MX Master, Microsoft Surface Mouse, only mouse with fully customizable touchscreen and multi-gesture input. Lastly, goals of testing to validate real-world performance, refine UX and hardware design, and position as a next-gen tool for productivity, creativity, and gaming.
For this section, I will explain our plan for the full-scale manufacture of the touchscreen mouse. First, the manufacturing timeline. We are targeting full-scale production within 12 or 14 months following the completion for prototype, refinement, and pilot testing. During this period, we will focus on finalizing both hardware and software based on user feedback. Next, our manufacturing partner. We plan to outsource production to a reputable OEM based in Shenzhen, China. Shenzhen is known as a global hub for electronic manufacturing, offering high quality, cost-efficient, and scalable production, especially in tech hardware. For our marketing strategy, we will implement a multi-channel campaign, including target social media ads, influencer partnership, and YouTuber review, and live demonstration and major tech expos like CES and Computex. This effort aimed to build excitement and show the real-world use of the touchscreen mouse. In terms of sales channel, we will offer the product to customers through platforms like Amazon, Shopee, and Lazada. At the same time,
will first B2B approach, offering bulk sale to school, design, college, and corporate client. Finally, our strategic goal to maximize market visibility at launch, position the product as a next-generation input device, and achieve strong adoption in both professional and educational sector. That concludes my part. Thank you.
Good day everyone, my name is Naresh and my model number is C23A097. Today I'm going to explain about the conclusion. The touchscreen mouse marks a major innovation and competitive purpose that measures accuracy of the traditional mouse with the ability of the customers and the touchscreen. Also, it means a growing demand for a smarter, multitasking-friendly tools across the creative, academic, professional, and gaming stores. It's like unlike accepting the product, it's like Apple Magic Mouse and their Logitech technology and Mac series. This device offers a fully attractive touch display with the gentle support and virtual customization, delivering a unique, intuitive user experience. Also, with a clear development roadmap manufacturing personnel and storage Apple to provide a user base, the touchscreen mouse is a positioning to become a next generation standard in productivity in the digital taxation. Also, more than a peripherals, it's a smart and innovative tool built that support future and content. Thank you.